The 24 is if you've got a slope of -3 and you know that you have 8 as your x value, you just trace that up, your rise up.
So you found 24 up here.
Yeah.
So he kind of mapped out the trade line. So those of you who are scared of this method, it's okay, you don't need to know how he did it here. So anybody else do it differently? Did anybody get that answer? Because I don't even know if he's right. That's different than the way I would have thought about it. So I didn't have this one worked out on paper, although I've used these numbers before. But I also have done this in other classes. I'm kind of losing track on which one is which. So we want to get back to 8 in this case, and we're sitting with all food. So really what we want to do is buy 8 cars. We want to buy 8 cars, right? Get back up to that point. And what does a car cost me? What is the price of a car? You should have that down. 1/3 of a food for every car. And so I use this notation for a couple different reasons. One, it kind of keeps track when you're not doing money, like are we talking cars or are we talking food? Also, when we get into exchange rates, when we start talking about currency and the Japanese yen and all that, then this will kind of come in handy when we start talking about that as well. So the cars cancel. 8 divided by 3 is equal to, what is 8/3? 2 2/3. Now that's what it cost me, right? We're going to buy 8 cars, giving up 2 2/3 of our, whoops, I got to put my own thing here, 2 2/3 of our food. 8 minus 2 2/3 is 5 1/3. Bingo, bing, 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 bing. We kind of have this overlap going on, right? So I'm going to give up 1, 2, and 2/3. So minus 2 2/3 gets me down to 5 1/3. So 5 1/3 lives right here. And that gives me a gain from trade of 1 1/3. I started with 4 because I was with no trade. I was at point A all by my lonesome, not doing any trade. I'm at 8 and 4. Now I have 8 and 5 1/3, which means I've gained 1 1/3. So point C now in this case, you had a C on there up here before. Now we've got a gain of 1 1/3 food.
If you look at it like you have all 24 cars and you sell 16 cars.
So basically you're thinking if you go up here, if I give up all 8 of my food, I could have 24 and then sell 16. Yeah, that's kind of an extra step, but there's nothing technically wrong with it. Yeah. So all of our brains might approach this a little bit differently. So I kind of think of it that way. There's even another approach to this. Point D was up here, right? And what was the gain in terms of cars? So this is like option number 1. Here, well, I guess you are number 1 here. We'll call you number 1. Remember that x equals 5 1/3, but that's not the gain. Therefore, the gain is 1 1/3 food. Option number 2 here is to think about, I own a bunch of food and I'm going to sell. I need to buy some cars. That's what it's going to cost me. Option number 3 is kind of a 2-stepper, but we take our gain that we had before, the gain of how many cars was it? 4,000. Is that what this was? Okay. So remember this was a 12 on your graph. Again, my graph's a little not to scale here, but we had 4,000. We had a gain of 4 cars. If we convert that gain of 4 cars, if we convert that now using our international price, we can convert that 4 cars using the international price of 1/3 of a food per car 4/3. What does that equal? 1 1/3. Bingo. Third way to think about it. So the gain is 1 1/3 food or 4 cars. You can think about it either way. I put the gain in terms of food, I put the gain in terms of cars. So that's 3 different approaches to thinking about how we made ourselves better off in terms of one good or the other. All right, now there's a problem with actually probably point C and point D, but let me bring you back to point D. The gain was 4,000 cars, and how much did Japan gain? Remember what their gain was? 6, right? So things are real rosy here. We got Japan gaining 6,000 cars. We got the United States gaining 4,000. We have a win-win situation, right? Win-win. We always look for those win-win things in life. Free trade is a win-win situation. Both parties gain by exchanging with each other. But there's a problem with point D. Anybody pick up on that? So the U.S. is at 12,000 cars. What is the amount of cars that they're consuming after trade at point D? How many cars were the Japanese consuming at their point D, D star? 16,000. So we got 12,000 for the Americans. We got 16,000 for the Japanese. So what is the world consumption of cars under that? 12 plus 16 is 28,000 cars. What is the world production of cars? 25. Houston, we have a problem, right? There's only 25,000 cars in the world. The Japanese made them all. So in other words, point D is not an actual post-trade possibility in the model. It's not possible. So this is bringing up an important distinction here between showing the gains from trade and what the actual post-trade amounts were. At the end of the day, in a two-country model, what I sold to you is what you bought from me. Globally, the amount of imports must equal the amount of exports, right? What I sold to you as an export must be what you bought from me as an import. Imports must equal exports. In the grand scheme of things, it's just accounting 101. If you go take Professor Wagner's class, debits equal credits type of thing. What I sold to you is what you bought from me. So we've got imports equal exports. So here's some key takeaways from this, some key points. Number one, we can show the gains in terms of either good. And I might add, or both goods. I could introduce a point like E in between these two, which would show, hey, we're up a little food and we're up a little cars, we're made better off, right? So the reason why we show the gains from trade in terms of one good is because it allows us to measure easier, right? To have a common denominator. Now, when we get to the real world, which we won't completely avoid in this class, by the way, I know this is fun playing with our toy box here, but when we get out to the real world, how do we measure gains from trade typically? What do we use? Money, right? Our gain was $1 million. Your gain was $4 million. That was the gain from trade, was measured in dollars. And so we're doing the same thing here, but we don't have money to do that with. So the real economy deals with real goods. And so money, again, is something that just helps facilitate trade. It becomes our common denominator. But this is really reflecting more meaningful information. Because what gives us happiness as human beings, if we get back to the real world for real, is not money per se, but what money buys, right? And so by thinking about things this way, where we're giving up a third of a food to get a car, we're talking about two things that are meaningful to us as human beings as opposed to money. Only what money buys is what we care about. So we're really thinking about the real exchanges in life when we convert the pricing system that's in terms of dollars into the actual goods that are being traded and reflecting the opportunity cost of what you're giving up to get that. Let's take a look at that real quick. Give me a good, any good. Pat. Give me your name again. I know I asked before, and I'll probably have to do it multiple times. Anthony, give me a good, any good. First thing that comes to mind, I don't care what it is. Coke. And let me go to this row. Give me a good, any good, any good. First thing that comes to mind, shout it out. Pop-Tarts. Coke and Pop-Tarts. Anthony, how big of a Coke are we talking? 2-liter case, 12-pack, what are we doing? 12-pack. So the price of that Coke is $3.50? $3.29? You make up a number. $3.29 it is. And Pop-Tarts, give me a name. Hannah. What are we buying? A big case of Pop-Tarts at Sam's Club, or are we just buying a single pack at Walmart? Little one. How much are you paying for that? What do you think? $4. For a little one? They aren't that much, are they? Two. Oh, two. Okay. All right. How about, just to make it fun, how about $2.07? How much? $2.39. This is kind of like that Price is Right game where you got to get close. Okay. So there's our prices. Now, one thing that we kind of do around the scene is look at the relative price. If you ask an economist what something's worth, they're going to say compared to what? Compared to what, right? Because that doesn't really mean a lot if we don't have some other information, whether $2.39 means anything to you, right? We don't know that. If we look at the relative price, it starts to make some sense, though. So what the relative price is we're going to take one price divided by the other price. And watch what happens here. So if we look at the relative price and we take the price of Coke at $3.29, and now we're going to buy $3.29 per Coke, getting back to this kind of notation. $3.29 per Coke divided by $2.39 per Pop-Tart. Somebody pull out a calculator. What do we got for $3.29 divided by $2.39? 137, so 1.37. But now the reason why I did this notation is, what do you do when you're dividing a fraction by a fraction? How do you solve it? Flip it over and multiply it times the numerator. So flip the denominator and multiply it times the numerator. Check this out. $sign Coke times Pop-Tart over $sign. Dollar signs cancel. And we've got 1.37 Pop-Tarts being traded for every Coke. 1.37 Pop-Tarts being traded for every Coke. Is that the price of a Pop-Tart or the price of a Coke? 1.37. What would you call that? The price of a Coke or the price of a Pop-Tart? Price of a Coke, right? So the thing down here is measured on a per unit. So it takes 1.37 Pop-Tarts equals 1 Coke, is kind of putting it back into this lingo. And there's your trade that's going on. Every time you buy a Coke, little did you know you're giving up 1.37 Pop-Tarts, right? That's the exchange. That's what's really going on in the world when we look at prices. Money is kind of the veil to the economy, is what I think Milton Friedman, if I'm giving credit to the right place. Money's like a veil to the economy. The real economy is behind the curtain, right? This is the real economy. You are making decisions and giving up things. Every time you buy a Coke, you're giving up something else. That's opportunity cost. You need to start thinking that way to make good, efficient decisions with your money. Okay, any other questions or comments there? All right, I wanted to bring back a little money stuff back to this trade stuff. They're all one and the same, or they do work together. All right, point number two is exports, which we'll be using the notation EX. I'll just write it out this time. Exports must equal imports. Exports must equal imports in the real world, or for actual post-trade quantities. So in our example, let me come over here for a sec. At point C and C star, we had Japan consumption at 16,000 cars. We had the USA's consumption, I'm just recapping what we already did. We had the USA's consumption at 12,000, which gave us world consumption equal to 28. But that is not possible. It's really not a possible point of consumption, because world production was equal to 25,000 cars. All Toyotas, all Japans, right? So world production was 25,000 cars, so that wasn't even a possible point. All I want to highlight there is stuff that we'll use later in the semester. Imports must equal exports when we start figuring out doing some global accounting of international trade. And that'll be a little ways out. Okay, any questions on that? All right, so we need to figure out where these world prices came from. It's going to be our next job. And then we're going to talk about some trade restrictions. When I gave you the 3 cars for every food, or a third of a food for every car, we just said, this will work. How about this number? And I want to think about what's the underlying factors that are driving the world price. And so we're going to touch a little bit on supply and demand, which is a chapter I don't officially assign. It's in your book, though. It's chapter 3. So we're just going to use some very minimal tools of supply and demand here as we work through this. So those of you who haven't had micro, this is not going to be anything that's going to be pushing what we really learn in chapter 3, but we'll have some basics of supply and demand. All right, so let's just title this Understanding Where the World Price Comes From. That might be a little too powerful of a statement, but I'm up for a challenge. So let's start off looking at Japan. And let's just say there's cars. We're going to kind of drift a little bit away from where we were before. But here we've got the price of cars, which could be in terms of food. And here we've got cars, the quantity of cars being measured on the horizontal axis. And from our example, without any trade, and actually I think I want to do food. What did, I think I just did a little faux pas there. Yeah, we needed, we're doing food instead of cars, so we'll just kind of go with the story. So sorry about that. Put a little food down here instead. Food and food. All right, so the price of a food without any trade was 1, 2, 3, 4, 5 cars. All right, so the price of food, we could kind of start to think about this as being $5 maybe if you want. And then we've got quantities that are getting bigger. This is our origin, so 1, 2, on down the road getting bigger here. So if Japan doesn't know that the rest of the world exists, then they are going to, I just want you to put any old point right here, they're going to produce enough food to supply or to meet the demand in their own country. So we get a good old starting place here, what I called home base and micro, but where the two lines cross is often where a lot of exciting things happen in economics. And so we have the supply of food by Japanese producers, right? So these are Japan's producers of food. They are the domestic producers. If we're looking at Japan, domestic production. And here we've got Japanese people, Japan's households. So we got Japanese people interacting with Japanese producers. They get together, they kind of battle it out. Where the two lines cross, something special happens, because if they're not where the two lines cross, then we don't have their needs being met one way or the other. And so this is the equilibrium price in this country. So if we come down to 2, for instance, let's just say that, just to pull a number out of the air, that the price of food happened to be 2 in Japan. The problem with that is that at a low price, the Japanese producers say, screw it, that's not worth my time. I'm not going to be making this amount. By the way, I should have maybe had a quantity here. I'm not going to make this much food. I'm only going to make this much food. So the quantity supplied, the quantity that they're producing, is here. Meanwhile, Japanese consumers love low prices. Don't you guys love low prices when you go out and buy stuff? Well, that's reflected in the demand curve in econ class. So at a price of 2, Japanese consumers are like, where do I get it? Where do I go? Give me my, let's get going. So the quantity that they demand is way out here. And that's the imbalance that I was talking about. People want to buy a whole bunch more than what's available. What did we call that, those of you who did have micro? A shortage, right? So we're short goods. People want more than what is being supplied. What's going to happen to prices naturally through the invisible hand that Adam Smith talked about? What's going to happen to prices in this country? What direction are they going to head? Do you think they're going to go up, down, or stay the same? I see a bunch of people saying up, right? So why? If you are running the business here and you open up your store and you have an 8-hour shift and at 10 o'clock in the morning you run out of food, what is that signaling to you as a business owner? More. Your prices are too low, right? I could raise my prices and still make money. I still got another 6 hours to go on my shift. First couple hours I'm sold out. So they have incentive to bump up prices. On the flip side, there's a lot of consumers that would like to get that food too. So they're either going to get to be there first in line, or they might tell the shop owner, hey, keep a little bit aside, I'll pay you double. I'll give you 4 instead of 2. Just don't run out. I can't get there until 4 o'clock today after I get off work, right? So both the consumers who are missing out on buying the goods and the producers have incentives to see prices go up. And so prices are going to tend to drift up. So the main takeaway here is that without any trade, 5 would be our number domestically. Other prices aren't really sustainable. Now let's introduce the concept of international markets. To the right of this graph, I kind of wrote a few more extra things that I don't normally do. I want you to think about there being a world market. A world market. Now on this world market, if the world had cars priced at 5, would Japanese consumers want to buy any of them? If the world had cars priced at 5, would Japanese consumers be interested in buying any of them? No, because they're paying 5 in their country. But if the world offered a price of 2, would they like to buy some? Yes, it's cheaper than what they have, right? So in fact, they'd like to buy this many. We already know that. And so this quantity, let's just call it 1,000, just to get a number going here. So at a price of 2, they don't care, by the way, they're not racist or biased or anything. They don't care if they buy it from a Japanese producer or some foreign producer. They could give a rip. They just care about prices, right? So they're looking for low prices. At a price of 2, they're going to buy this much total. This much is being produced by the Japanese producers, but this amount is short. That's our shortage. And so if this ended up being 200 down here, 200 units are being supplied by Japanese producers, 800 units are being short. And if the world price was 2, so the reason we drew these side by side is that we're going to go dot, 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 dot. If I take this horizontal distance and I rip it off the board and I transplant it here, this number is 800. They would like to buy from the world market 800 units if the world price was 2. So here we've got the world price of food. Here we've got the domestic price of food. At a price of 5, they say no thank you. So that's another point. As price starts to fall, if you take another chunk out of this, wherever you want to take the chunk and chunk it over, what would end up happening is you're going to put things right in a straight line. And now that becomes the world demand or excess demand for food. In the international market, we've got a new thing of the world's demand for food. So this is sometimes called the excess demand curve. The demand that's above the domestic production. Okay. What was the price over in the United States? In our example, what was the opportunity cost of food in their country? What was that? Look back in your notes there. What was the opportunity cost of food in the United States? One of the very first things we did, I think, when we set this up last time. 2, right? So that's where we learned the United States had a comparative advantage. in food because they could do it cheaper than in Japan. The Japanese people could only do it for 5 cars is what it cost them to make a food, whereas in the United States it was just 1, 2, 3, 4, 5. Let's go up 2. And what that means is that given the resources available in the United States, there was a supply and a demand for food that looked like this, and the equilibrium price domestically was 2. And again, we can start to think of maybe $2 is fine now that I'm tying it, but it's not a perfect tie to what we did before. But conceptually, I'm hoping it helps. Now, if price was higher, would U.S. consumers buy more food or less food? If price of food was higher, would U.S. consumers buy more food or less food? Less, right? Which works well into that fat and lazy thing. Maybe the less food won't be too bad, right? All right, so we got that going on. At a price of 5, arbitrarily speaking here, the quantity demanded by U.S. consumers, remember this is U.S. consumers, these are now U.S. producers, they're going to be buying less food. Producers at a high price of $5 is like, yeah, let's till up some fields, man. Forget nature. Let's get those fields plowed under, baby. We got some food to make, right? Take away some of that conservation reserve property. You know, money talks. Here we go. And they're going to want to supply this amount. So the quantity supplied at a high price of 5 is that amount. If they don't trade with each other, is this sustainable? Is a price of 5 sustainable with no trade? No, it's too high. They're producing all the food, but it's just rotting away because consumers are only buying this amount. What did we call that in micro? A surplus. So there would be a surplus of food at a high price of 5. However, what if there was a world market to sell that food on? What if there was a world market to sell that food on? And we're looking at the world price of food. At a price of 5, ... they have this extra food that they're going to now supply to the rest of the world. So this distance here ends up being equal to this horizontal distance. Boom. If price is $2 around the world, are they going to supply any to the world? If the world price happens to be $2, are U.S. producers going to sell any to the rest of the world? No, because Americans are buying all that they're producing. We're in equilibrium, so there's no problem. The quantity supplied equals the quantity demanded at a price of 2. So at $2, the world gets nothing. At $4, the world gets this much excess surplus. At, who's up? Who's our ringer? Hunter? Oh man, you need these points. All right, that's all right. It happens. Happens to the best of us. All right, so remember to shut off those digital devices. At a price of, this is a 5. What the heck did that come from? So we got a 3 here instead. At a price of $3, the United States is going to dump this much onto the world market. And so this ends up creating an excess supply curve. So we could also call that an export supply. And over here, this excess amount that they wanted to purchase could be called maybe the import demand. And now we start to see things coming together, right? We got a buyer, we got a seller out in the world market. All right, questions on the setup. Then we're going to do the real fun part here, if everybody's okay so far. All right. I'm going to get rid of this. Let's put it all together. So put 3 graphs side by side with each other. 1, 2, 3. And I want you to start off by putting these little dashed lines in. So I want you to try and kind of draw this carefully this time. Make sure you draw a big enough graph. And go ahead and do the 1, 2, 3, 4, 5, nice and evenly spaced. And then I want you to carry those dashed lines all the way across the page, all the way across all 3 graphs. All right, something looks like that. And you can mark 1, 2, 3, 4, 5 along the. Oh, geez, this is lovely. Now this time you can use your own creativity if you want. We can go ahead and put Japan here. And we're going to put the United States over here. And then we're going to have the two meet in the middle in the world market. So this is the world market. 1, 2, 3, 4, 5. Remember the Japanese had a supply and demand curve that crossed here. And when you draw these, I don't care if you make them short or fat or steep or whatever you want to do. Just make sure you have them crossing up here. And don't have them go so much that they go off the edge. Have them end down here. But you can make one pretty steep if you want. Steep or flat, doesn't matter. That again is the supply and demand curve for Japan. Next, I want you to come over to the United States and do the same thing. Remember that they are at 1, 2, 3, 4, 5. They are at 2. Pick a point anywhere in the middle. Draw a couple lines through. All right. If world prices are not different than domestic prices, they're not going to trade. So next thing I want you to do is mark off Japan's point where if prices are at 5, if the world price is 5, they're not going to do anything. If the world price is 2, they're not going to do anything. The United States is not going to enter the market. We're getting a little bit closer to reality now. in the real world, what must be true about imports and exports? They got to be equal. So I got an eyeball trick for you to do. We're going to derive the world price, and since you guys all did your own slopes of whatever those demand and supply curves look like, at the end of the day, the prices are going to fall this way, making this get wider. Over here, as you move up, this gets wider. So I want you to put your left eyeball at this point, your right eyeball at this point, and I want you to go up here and down here until you find the point of equilibrium where imports equal exports, and the horizontal distance between the two is going to be equal. All of us are going to have different answers potentially, right? Because we all drew something different. So go ahead and do that. Let's see here. Mine looks like it's right here. And now, you can connect those 2 points, or those 2 horizontal distances, and transplant one of them, which equals the other one. And that is where the import demand and import supply, or export supply curves are going to intersect with each other. So we got the import demand, we got the export supply, and I don't know what you guys got, but I got $3.53 is what my world price is. You guys might have anything between 2 and 5. Just kind of do that eyeball trick and see where imports equal exports. So here's the amount. This horizontal distance again is the distance, the difference between what the quantity supplied is by Japanese suppliers and the quantity demanded. And this ends up being the amount of imports, because otherwise there'd be a shortage. So instead of there being a shortage like we learned in micro class, those of you who had it, we're just going to buy that from the rest of the world. And over here, the United States, what used to be a surplus because the quantity supplied exceeds the quantity demanded, those producers are now able to export their product to the rest of the world. And this is the equilibrium world price of food. What drives world prices ultimately is the existing resources and preferences of consumers in each nation. This demand curve reflects American consumerism. I want to put it in those terms. This supply curve reflects the resources used in the production of food in the United States. So whether it's steep or whether it's flat, the shapes of those curves are reflecting Japanese consumers, Japanese resources. And the great equalizer is trade. Imagine all the people. Right? We got this thing, living things and bees cooperating with each other. One of the beauties of the market is the impersonal cooperation that goes on. We don't know what's going on in Japan. We don't know if they like us or not. But yet we trade with each other and we make each other better off. And we're able to agree on a price that's in the middle that does just that. We actually cooperate with each other. We don't compete with each other. It's the great cooperation. And I'll leave it with that little Lenin song and have that in your head.